you ask you how many odd numbers exist between two numbers, most beginners immediately start looping through every numbers but checking odd and even manually. But what if I told you, can you solve this OF1 time complexity and const base complexity using pure math logic? And that is what makes the problem super interesting. Today we will solve LeetCode question number 1523. Count odd numbers in an integer range. So, using mathematical operation, optimized logic, and visual simulation, beginner-friendly explanation, and optimized code. So, let's start. Hello everyone, welcome back to my channel. Myself Priyaval. On this channel, we solve LeetCode problems, visual explanation, animation, and optimized code and beginner-friendly logics. So, practicing LeetCode, you are in the right place. And if you are having new year, make sure subscribe. We upload the coding content regularly that makes DSA and fun the understand to better logics. So, starting from the given problem statement, we are given two integers, first low and high, and count how many odd numbers exist between them. So, here given an example, low equal to 3 and a high equal to 7. So, your output is 3. Now, the odd number between 3 and 7, normally having the odd number is 3, means 3, then having 5, then having 7, means 3 odd number exist. After that, here given another example, low equal to 8 and high equal to 10. Here the output is 1. The odd number between 8 and 10 is 9. So, the count is 1. So, what our approach to solve this question? Start from brute force thinking. Normally, now beginner usually think that transfer from low to high after check every number, then count the odd number. But it's yes that work. But the complexity of this question is on. We can do better. Yes, we can do normally better to this approach. So main optimized observation is that now here comes the most important observation. Between every two consistent number means one is even and one is odd. That means half of the number are odd. So we take high minus low divided by 2 give the almost answer. But that's one important edge cases is there. If low is odd or high is odd, that means one extra odd number is exist. So the simple add be that brilliant and simple logic of this question. Now what our approach normal step by step. First we take step 1. Find the count means high minus low divided by 2. Then go to step 2. If low or high is odd, then we increment the count. After that, we return the given answer. It's no loop needed. It's a optimized code of this question. Now, we visually represent to this question how it's work. So, it's a visual representation. We take an example 1, 3 and 7. General simulation of this code. Here having a simulation. Here 3 to 7 having 3, 4, 5, 6. Now we start the simulation. Having 3. The odd count is 1. Having 4. The odd count is now 0. Having 5. The odd count is 2. Having 6. Having 7. The odd count is 3. That is the output of the final output of this question. This is a visual simulation of this code. Now we write the code. So here we write the code. First we take int count equal to, we take high minus low divided by 2. It gives the count 1. After that, it's give count 1 after that we not run any of the loop. Then we check if condition. If having high, it's a odd one, then low having an odd one. Any of those conditions is satisfied. Then we increment the count. So we write high modulus 2 not equal to 0 or low modulus 2 not equal to 0. Then we increment the count. So we write count plus plus. After that we return the count. So we return count. Here we return the count 1. Now we run the code. Given example, it's work or not. The given example code is run. Now we normally how its code work. So we take a dry run of this code. We take an example number 1 to dry run. So here we take the example number 1 for dry run. Here low equal to 3 and high equal to 7. Here we in the code we take an integer int count equal to we write that high minus low modulo divide by 2. It means here we check high having a 7 minus low having 3 divide by 2 means it gives 7 minus 3 is 4. 4 divided by 2 it's give a 2. Answer is 2. Then we check then the count equal to now is count equal to 2. After we check the low one and high one is odd or not. So we write the condition low modulus 2 not equal to 0. That means we write here 3 modulus 2 its answer is 1. It means the count it means it's a odd number. We check low one, otherwise we check high one. Here low one is satisfied means the count 1 is increment. So the count initials 2 then increment 1 its count is 3. So the given question answer is now 3. Now we submit the code. Here, all the test cases are passed of this question. Now, the time complexity of this question is OF1 because only mathematical calculation, no for loop we run. And the space complexity of this question is OF1 because no extra memory is used. It's a fully optimized code. So, why this approach is best? This solution is amazing because no loops, pure mathematical logics, const time and const space and optimized code. This is powerful of pattern observation and math optimized and logical thinking. And normally when starting the code as a beginner, the common mistake to solve this question is most beginner use loop unnecessarily and forgot inclusive range and missing the edge cases, forgot odd numbers condition. But our approach is worth and avoid this all the mistakes is. So whenever you question involving here, even an odd pattern, internal counting, range, you think about mathematical operation patterns and avoiding transversal. Sometimes math beats the brute force complexity. In this video, understand the internal math optimized clearly. Hit the like button, comments for daily DSA and LeetCode content. Comment the next problem you want to solve. If you enjoy the visual simulation, make sure turn on the notification bell. And because we build one of the best beginner friendly coding community together. So thank you for watching. Keep coding, keep learning, keep improving. See you in the next video. Thanks.